Today's lecture is on fish and shellfish. So for anybody who has spent time in the fish department at your grocery store and you look at what's available, there's really only a few kinds of fish. And that's because there's really only very few of them that are commercially fished for the regular food supply. There's roughly about 20,000 known species of fish in the world, but only about 250 of these are fished commercially in the US. If you go to different countries, you are going to find a greater variety of different types of fish than you would see here. And for the average American, consumption is roughly about 3.5 ounces per week. This slide shows everything that falls under the broad classification of fish. There are two major divisions, fin fish and shellfish. And as we're going to get into in the lecture, we're going to see that the muscular structure of fish and shellfish is really different than what we've seen with the land animals. And the reason for that is gravity. Fish and animals that live in water don't need the same muscle structure because they're not dealing with gravity every time they have to move. So we'll talk about that in a little bit. But for right now, what I just want you to understand is under the fin fish, those are typical fish that have fins. Underneath that, it breaks down into freshwater fish and saltwater fish. And each of those varieties have very lean fish, so there's not a lot of fat on the flesh, or they can be a little fattier, so it kind of depends on the fish. On the shellfish side, we have two different categories. The crustacean. Crustaceans are anything that have an outer shell, like an exoskeleton is what we refer to that as. So those things like crabs, lobsters, shrimp, they have some sort of a tough exoskeleton. Those are the crustaceans. And then there's the mollusk group, and that's anything that's actually in a hard shell that is either a bivalve, which is an animal that has two shells on it, like say a clam or a scallop has a top shell and a bottom shell that are hinged together. Those are the bivalves. Univalves, those are anything that has one cell. So a snail fits into that. And escargot is, if you've ever eaten escargot or ever prepared escargot, snails are treated the same as fish. They are cooked in the same way as fish because from a culinary standpoint, that's what they respond best to. So abalone and conch also fall into that category. And then finally we have the cephalopod group. The cephalopods are octopus and squid. Cephalo means head, pod means foot, so it's literally head foot. And it may appear that squid and octopus don't have any sort of a tough shell structure that is typical of the mollusks, but that's not true. Their shell is actually inside. It's internal. If you've ever cleaned squid or octopus, they have an internal structure called a pen. P-E-N, just like a writing instrument, pen, that is very tough and provides some structure. So that needs to be removed before the animal is eaten. Fish can also be broken down into whether or not they're vertebrate or if they are invertebrate, and what that means is whether or not they have a backbone. So a vertebrate, those are your fin fish. So if you've ever cleaned a fish or looked at a fish skeleton, you'll notice that they do have some sort of a backbone, and their skeletons, of course, are internal. Invertebrates are what we were just talking about with the shellfish. They have some sort of a hard supporting structure, whether it's on the outside or the inside of the body. So like we were talking about with the crustaceans, it's on the outside of the body, and the mollusks, it's also on the outside of the body, with the exception of the cephalopods that have the internal pen. If we look at saltwater versus freshwater fish, in this country we tend to eat a lot more saltwater fish. It figures prominently among what you find in the grocery store. Some of the fish actually live both in salt and freshwater, and salmon is a really good example of this. It spends part of its life in saltwater and part in freshwater. Saltwater fish tends to have a more pronounced flavor than freshwater. That's not a rule of thumb, but it's just a tendency. Many times there's a much stronger flavor. So if you think of the saltwater fish, things such as salmon and swordfish and tuna, they have very, very distinct flavors so that you know what they are. Many times freshwater fish doesn't have quite as pronounced flavor, but this is also further determined by whether or not these freshwater fish are very fatty. Some very fatty freshwater fish can have a more pronounced flavor just simply because of the fat content. So saltwater fish, we're talking about the ocean. Freshwater fish, we're talking about rivers, lakes, and streams. So some good examples of freshwater, as you see on there: catfish, pike, perch, trout, and saltwater you see listed up there as well. Generally, fish flesh is much tender than a land animal. So if you were to compare a fish fillet to a piece of pork or a piece of beef, and if you just run your hands over it, you can tell that it's a lot more delicate. And a lot of this has to do with what I mentioned before about how animals in the water, who live in the water, don't have to deal with gravity. So they don't need necessarily that same toughness that comes from gravity. And probably the best example of this is in the collagen content. Collagen, if you remember from the beef lecture, we talked about how the more hard work muscles do, for say a cow, that walking animal on the ground, there's more connective tissue involved in that. So these muscles are working very hard. That's not to say that fish don't swim very hard and they're not active, but they don't have that gravity portion that is really sort of slow, really sort of requiring harder work. So as a result of that, as you see here on the slide, fish only have about 3% collagen in their tissues versus about 15% for land animals. So that's one thing that contributes to the tenderness, because remember, the more collagen a tissue has in it, the tougher it's going to be. Fish collagen also converts to gelatin at lower temperatures. So if you've ever cooked a fish fillet and it's, you've roasted it or put it in the oven and you pull it out, you see sort of a white kind of jellied substance around it. Well, that's that fish collagen converting into gelatin. And it's actually interesting, the original gelatin, before we had Jell-O, the original gelatin was something called isinglass, which sounds like an interesting word, but it's actually gelatin. It's derived from fish tissues. And so before there was Jell-O, chefs used to use isinglass to create gelatins. So rather than coming from beef, gelatin came from fish. The amino acid hydroxyproline is also key in why fish is very tender. It causes a collagen breakdown to occur much more easily than it does in the land animals as well. And then finally, the muscle structure is very different. In an animal muscle, a land animal muscle, the muscle fibers can be very, very long, extending the entire length of a full muscle. So if you think of a leg muscle or something like that, it's going to extend the length of that muscle, so it can be very, very long. Fish, on the other hand, they're very short fibers, as we'll see in the next slide. If you've ever looked at a fish fillet or a side of fish, this probably looks somewhat familiar to you. Um, I think it's best seen in a dark-fleshed fish, so something like salmon. You have the pink flesh, and then you can see all of these little divisions in there. Muscle fibers themselves are called myotomes, and they're very short, as you can see in this diagram here, very, very short plates that go all the way down the fish. And dividing the myotomes are a very thin membrane. This is where the collagen is. That's called myocomata. And so if you've ever looked at a dark-fleshed fish and you've seen, well, let's go back to the salmon, the pink flesh of the salmon, and then you see sort of a faint creamy white divisions in the pattern that you see on the fish up there, that's the myocomata. That's dividing up all of the short muscle fibers in the fish. And if you haven't seen that before, next time you go to the grocery store, stop and take a look at the fish, and you'll see this pattern on any of the fillets that you see sitting out there. The myotomes and the myocomata, combined with the very, very short structure of that muscle tissue, is responsible for the flakiness in cooked fish. If you've ever looked at a recipe for fish, sometimes they'll direct you to tell when the fish is finished by putting a fork in it and twisting it a little bit to see if it flakes, and that is a good indication of doneness. One of the things that I find a lot is that people are afraid to cook fish because they're afraid they're going to overcook it and it's going to be dry. They don't really know what to do with it. And if you're careful when you're cooking fish, following the recipe, and taking a fork at the end, putting it directly into the fish and just twisting very lightly, what happens is that some of those fish flakes, if they're easily released, but the fish still appears moist and it's opaque, that is, the fish flesh is not translucent, it's been completely denatured by the heat, then it's finished. So cooking fish takes a little bit of practice, but the flakiness is one of the things that you can look for. We're going to talk a little bit about myoglobin. If you remember from our beef lecture, we talked about myoglobin being the pigment that gives meat its color. And unlike beef, fish flesh comes in a lot of different colors. As we learned with the land animals, harder working muscles are darker than lighter working muscles. Because there's just more concentration. Those muscles in life need a lot more oxygen, so there's a lot more myoglobin there by necessity. In fish, the typical flesh colors that we're looking at are generally white or sort of an off-white, grayish sort of color. Pink and red are not uncommon either. And in fish, many times, if it's a smaller fish, they will have sort of a uniform distribution of myoglobin throughout their flesh. Some fish, larger fish, tend to have a mix of harder working muscles and lighter working muscles. So, as we said, darker pigments where there's more myoglobin. We tend to see darker flesh in fish that have what we call slow twitch fibers. So the muscles, they're not rapidly firing commands to move, they're coming much more slowly. And we see these in long distance swimming fish. So these are fish that go a really long ways, but they don't go particularly fast. They just are continually swimming, sort of like a marathon runner. Darker pigments with these fish, we also sometimes happen because the fish flesh has more fat in it. So the higher the fat, the darker the pigment is going to appear. Lighter pigments, you have fish that have very, very light colored flesh. they're not endurance movers. They're really sort of not moving very much at all unless there's something that is trying to eat them. So they're trying to get away from predators. And so what they have are fast twitch fibers. They move very, very quickly, but in very short bursts. And sole is a really good example. Sole is a type of flatfish, and it pretty much spends its life laying on the floor of the water, body of water, and kind of covers itself up with sand, and it just sort of lays there and doesn't do a whole lot, just sort of waits for food to float by. However, if there's a predator nearby, it can move very, very quickly, but it can't do that for a really long time. So the muscles of the sole are very light, because they're not heavy working, they're just short bursts. And there's not really any darker pigments in there, it just tends to be all light. So as I said, some fish are made up of different types of fibers, and the tuna is a really good example. And this is a tuna. Now, the reason I put this on here is because I think that here in the US we're so used to seeing our tuna in cans, we don't really know what the actual fish looks like. Tuna is a very, very big fish, as you can see here in this photo. It's a very big, very heavy fish, and it's made up of light meat and dark meat, and that's because certain parts of the fish are for endurance swimming, and so it can become very dark. Interestingly, the very dark flesh, very dark, strong flavored tuna flesh is not as popular here in the United States. They tend to favor it a little bit more in Asia because they prefer that strong flavor. Here in the US we get the light meat because it's not quite as intense. If you ever had a chance to test salmon in sushi and you get the really, really dark stuff, you'll see that the flavor is much more intense. The most intense salmon, or I'm sorry, the most intense tuna is from what's called the bloodline, and it's actually not a blood vessel, but it's an area of the tuna that has a hyper high concentration of myoglobin in it, and it is. I've tried it. I tried it when I was in culinary school, and it was so intense. It's almost metallic tasting. I found it rather unpleasant, but in Japan it's a really big deal. So it's just sort of an example of cultural differences in tastes and what we prefer here versus in other countries. When you go into the supermarket, you're going to find fish available in a lot of different forms. Fin fish is available from what we call whole or round fish, which means that it's just as it was when you pulled it out of the water. It's not really common to find that in the grocery store. That's something you're going to see a little bit more, well, if you're going fishing, obviously, that's what you're dealing with. But in terms of the grocery store, this is not one that you're typically going to see. This one needs to be cleaned and gutted and all that. So this type of fish is also called in the round. Drawn fish is basically where the organs are pulled out. So it's pretty much the fish is intact, but none of the organs are there. And so this is the first type of fish you would see most commonly in the grocery store, and as well as all the other forms as we see here. So that's called a drawn fish, when it's completely intact except for the organs. Next we have the dressed or the pan-dressed fish. So that is the organs have been removed, the tail, the head, the fins, those have all been removed. So you have this long piece of fish that's essentially the fillets on both sides. Many times this is cut into steaks, as you can see there, and you get sort of a U-shaped fish steak. That's where that comes from. You might also see single fillets where the entire side of the fish is removed. The skin may be on or off. and those fillets may be further cut into smaller steaks. And then there's also a butterfly fillet, which is a different cut. So these are all the different types that you might see in the store, but again, everything from the drawn fish down are the ones that we see most commonly in the grocery store. Let's turn our attention to culinary considerations, and we'll start with fin fish. Fish is the only food that when it smells like what it is, it's actually gone bad. So the thing that you never want is fish that smells like fish. That's an indication that the flesh has already started to break down and is deteriorating. So when you get fin fish, or any kind of shellfish for that matter, the smell should be rather neutral, and it can smell very faintly like salt water, but that's really all you should be smelling on it. If you're buying fish that has the skin still on it or the head still on it, the things that you want to look for are very tight scales. You don't want, if you run your fingers down the fish, it should feel very smooth. Shouldn't be any bumpiness, unless that is part of the way the fish is supposed to feel, and some fishes do have that. If the head is attached, it should have clear bulging eyes. You don't want sunken in eyes or cloudy colored eyes. The skin should be very bright and shiny. The flesh should also appear very shiny. It should be moist, plump, and it should be also the correct color for species. So, a true salmon color, if you are a fan of that, you'll want to know what color that is. Look for wild-caught fish. Farmed fish, farmed salmon, for example, a lot of times has artificial color added to it, and they put that color in the feed, so it's not really a true color. The other thing that you want to make sure of is that there's no gaping of muscle tissue. And if you look at the two fillets that I have up here, the one on the top, there's no gaping. That's the muscle tissues are very tight together. They're clinging to the myocomata, and it is very smooth. If you run your fingers down that, it would be very smooth. The fish fillet below that has gaping, and what gaping means is that either the fish has been physically damaged somehow, or there is a breakdown of the myocomata, which is causing the myotomes to pull away from it. And so those gaps that you see are just gaps between the membrane and the meat itself. And that is a sign of old fish. So if you have that going on, don't buy it. That fish has been around for a while. Shellfish is available in a lot of different forms. You can buy anything from live shellfish to any variety of processed. So it could be in the shell, it could be shucked. Shucked is simply when the shell is open and the meat is removed. You can buy it raw or cooked. The thing about shellfish, and this holds true for finfish as well, is it's very, very highly perishable. And you want to buy it as close to the time you're going to use it as possible. Shellfish and finfish are not something that you buy and then just put in your refrigerator for several days until you get around to it. The only way you can do that is if they're frozen, and then you can pull them out and do what you want. But if it's fresh, you need to use it pretty much that day or pretty quickly, maybe the next day. Shellfish tends to keep better if it is minimally processed, and so if it's left in the shell, or better yet, if it's live when it's bought, you tend to get a better product. When you're selecting a live mollusk, you want to make sure that the shells are closed. If you see a shell that's open, if you tap on it, if it snaps shut, then it means that the animal is alive, and it's going to be very fresh, obviously. If it doesn't close, then you want to discard it because that animal has likely died. You want to discard any shells that are broken, and obviously anything that has a not good odor or anything that floats. So we're talking about the mollusks, particularly the bivalves here. Shellfish forms commonly seen in the grocery store, as I've said. You can see live and shell, whether we're talking about lobsters, which is a crustacean, or mollusks. Shucked means simply, as I said, the shells have been taken off. So that applies to anything from an oyster to a shrimp. Headless, so in the case of shrimp, you see the picture here, I've got shrimp that is still has its heads on, so we don't see that real often in the grocery store, but that's what the whole animal looks like. More often than not, the head has been taken off. And you can also get it cooked. So if you go to the grocery store, you can see it shucked and headless and already cooked, and you don't really have to do anything with it at that point. But those are the most common forms that we see in the grocery store for shellfish. If you buy live mollusks, live bivalves, then obviously you're going to have to kill them somehow. And this can be done in a pan of hot liquid, or they can be shucked. And shucking is actually can be rather dangerous if you don't know what you're doing. The picture that you see here shows the process where a knife is inserted at the back of the shell where they connect, and you have to sever the hinge and then pry it apart. When you do that, it kills the mollusk inside the shell, and so that's done with oysters. Obviously you want to protect your hands with a towel, or some people use mesh gloves. It looks like chainmail, and that'll protect your hands from the knife as well, because if that knife slips, you're gonna have some problems. Crustaceans many times can also be purchased live, and I find that people sometimes have a really difficult time with this because it means having to kill the animal in your kitchen. And there are different, people have different feelings on that. Some people are okay putting the lobster in the boiling water. The way that I learned it at culinary school is actually to take a knife and position it, if we're dealing with lobster, to position it right between the lobster's eyes and then stab down, and it kills the lobster instantly. There's a similar technique for crab. So if you're kind of squeamish and you're not really, that's not really your thing to do, then your crustaceans and shellfish, you might be better off buying those pre-processed and already shucked and taken care of for you, so you don't have to do it. As far as culinary considerations go, fish and shellfish are pretty versatile. You can use both dry and moist cooking techniques with them. Although, as a rule of thumb, the amount of fat that is in a fish or the shellfish, the more natural fat that it has, the more aggressive you can usually be with it because the flesh is a little bit stronger. So if you have a very lean fish or shellfish, tends to be a little bit more delicate. You want to be more delicate with your cooking technique. So things such as poaching, steaming, frying, like shallow pan frying, those all can work pretty well. Broiling actually can also work very well. You're not handling the fish so much, and the heat is a little bit more gentle. Fattier fish, generally you can be a little more aggressive with as far as the heat and flame and things like that. Broiling, baking, grilling, barbecuing, the higher fat the fish, the better result you're going to have with that. This is a slide that just shows the fat content of different fish and shellfish. So you can take a look and see which ones qualify as fatty and which ones are considered to be more lean. So the lean ones generally have less than about 5 grams of total fat per serving. The very fatty ones can have upwards of 10 grams. So and then some of them, of course, are very fatty. Those are the mackerel and the salmon, king salmon in particular, that have quite a bit of fat in them. So they're going to have more pronounced flavor. As far as seafood inspection and grading go, there is no mandatory system in the United States for this, which I think a lot of people find surprising. But the thing with the inspection is that most most seafood producers do engage in inspection, and that's because, as we'll see, in order for their seafood to be graded, it has to be inspected. And grading is really a marketing tool to let the consumer know what they're getting. So higher grades, people are more likely to buy higher grades because they want better fish. So there's no mandatory inspection or grading system in the U.S. It's all voluntary, but as I said, most seafood producers do engage in inspection. It's based on the criteria of wholesomeness. And if you remember in previous lectures when we talked about wholesomeness, we talked about it as the criteria of just being safe to eat. It doesn't matter what it looks like, but it's not going to make you sick if you eat it, so it's wholesome. The National Marine and Fisheries Service, which is housed within the Federal Department of Commerce, is the body that conducts the inspections. And the inspections are actually paid for by the seafood producers. So not only do they conduct inspections, they also, the Department of Commerce also certifies certain shippers to distribute shellfish from certified waters. And so they may certify a particular body of water as safe, doesn't have excessive microorganisms, and really has nothing that is going to make the shellfish that grows in it unsafe for human consumption. Any seafood processor, repacker, or warehouse, they're required to follow what's called a HACCP system, HACCP, and that stands for Hazard Analysis Critical Control Point. You don't need to know that for this class, other than that it is a system that it helps during the processing of fish and the storage of fish and seafood. It's certain steps that the processors have to take to keep that their items safe. So keep them in such a way that microorganisms aren't going to grow in them, and they're not going to produce toxins and so on. So it's another way to make sure that the seafood is wholesome and safe for human consumption. Ultimately, the Food and Drug Administration has final authority over all shellfish commerce. So, as I mentioned, only inspected fish can be quality graded. So in the United States, we have 3 different grades. We have U.S. Grade A, U.S. Grade B, and Substandard. Substandard is pretty much what becomes cat food. U.S. Grade A is what you're going to see when you buy, when you actually go to buy fish itself. It's generally going to be Grade A, and the lower grades are going to be more what you would find in a like a frozen breaded product. If it's got defects, it's not quite as visible under the breading. The grades are based on appearance, texture, uniformity, good flavor, fresh odor, and the absence of defects. So much like any of the other foods that we eat, grading is a quality indicator that the higher the grade, the more likely people are going to be want to buy it. And I've actually just noticed in the picture that I have here of the salmon, you can actually see the Myochomata really well, those sort of whitish stripes on the dark fish. You can see the Myochomata there, so that's what I'm talking about. Breaded fish are graded in terms of their breading and how much actual fish flesh in relation to bone you have. As I mentioned previously, storage of fish and shellfish really should not be long. If you're going to buy fresh fish or shellfish, you really need to plan on using them. Ideally the same day you buy them, but no more than 1 or 2 days. In the cases of both, you want to keep them in the very coldest part of your refrigerator. And you may even consider storing them on ice. If you go to the grocery store and you look in the case where they have the seafood, it's almost always stored on a bed of ice. And this is because fish flesh deteriorates very quickly and very rapidly if the temperature conditions aren't really cold. It just breaks down and it just goes bad. So in the refrigerator, you want to keep it between 30 to 32 degrees. That's hovering near freezing, but it's pretty darn cold. So it's as cold as you can get it without freezing it. Generally best used within 2 days of purchase. And then shellfish really should be eaten the day that you buy it, especially if it's live. So shellfish also does really well stored on ice, and temperature again near freezing, 32 to 40 degrees. So when we talk about using fish as food, one of the things that we have to address is the issue of mercury contamination. And there are a lot of people out there who are very confused by what that means, whether or not they should eat fish. And the dietary guidelines for healthy Americans, as we'll see in the next slide, really does encourage regular fish intake because it's got a lot of health benefits to it. But in getting those health benefits, there are some other things that you need to keep in mind. And the first thing is that the type of fish or shellfish that you're eating, it's a really good idea to sort of mix it up and not eat just the same one over and over again as much as possible, because if you're just eating one type of any kind of food, really, you're absorbing all of the risks that may be associated with that food, and you're multiplying them because that's all that you're eating. Whereas if you mix up the different types of food, you're not only getting benefits from a variety of foods, but you're also not absorbing all of the potential dangers in whatever food that you're eating. So if we're talking about fish, let's say you're eating a larger predatory fish. So let's take a look at this here. Mercury levels are very high in these types of fish because not only do they have their own mercury content from the environment that they're in, but they also eat smaller fish. And so in doing that, they absorb the mercury content of all the fish that you're eating. So if you really like swordfish and you happen to eat it a lot, you are really putting yourself at risk for mercury poisoning yourself. Whereas if you eat several different types of fish as a part of your regular regimen, you're going to dilute that risk out somewhat. The FDA says that pregnant or breastfeeding women and children that are younger than 8 years old should avoid fish known to have high mercury levels. So Hg is this abbreviation for mercury. So if you don't fall into those groups, you certainly want to eat fish. It's good for you, but just keep those guidelines in mind. And speaking of the dietary guidelines for Americans, this is what it says about seafood. Increase the amount and variety of seafood consumed by choosing seafood in place of some meat and poultry. And if you remember from the vegetable proteins lecture, it also encourages people to use vegetable proteins in place of meat and poultry. So this is an ongoing message for the dietary guidelines. As we said, the wise way to do this is to use a wide variety to avoid the problem with mercury contamination. And animal fats are something that have traditionally gotten a bad rap, and the fish fat is really the exception to that, and that is because of the omega-3 fatty acid content. So fatty fish are really, really good sources of omega-3 fatty acids, and omega-3s are the focus of a lot of nutrition research, have been for quite a few years, and they've been linked to reduced risk for heart disease, cardiovascular disease, and a lot of other areas, but the cardiovascular disease has probably been studied the most. Despite all the research, the recommended daily amount of omega-3 fatty acids is not real clear, although 250 milligrams per day may be helpful for cardiac disease prevention according to the latest research, but there's no set amount for this yet. It is, including fish as a regular part of your diet, though, can help you get toward that daily amount of omega-3s, which may be helpful. And this is a slide simply showing the omega-3 fatty acid content of a 3-ounce cooked portion of different types of fish. So you can see the really fatty fishes, herring, mackerel, salmon, tuna. Those are generally more than 1 gram per serving, and in many cases much higher than that. And the ones below that are good sources, but have a little bit less, so they're not quite as fatty as the ones at the top. I'm going to wrap up the lecture by talking a bit about sustainability, because this is something that has come up over and over again in the argument as to how much fish we should be eating or the type of fish. We know that it's healthy, but at the same time, certain types of fish have been overfished, and it's really put a stress on the environment. If you remember to the first slide in this lecture, we talked about 20,000 different types of fish, but in the United States, only 250 of them are fished commercially. And of those 250, how many do you typically see in your supermarket? Probably less than 10. So the ones that we see in the supermarkets are the most popular ones, and there's a lot of concerns about overfishing certain species. There's actually a culinary trend going on that chefs are looking at fishes that we don't typically eat and trying to figure out how to popularize them and how to make them work a little bit better. So just a small way to kind of help this problem out. Sustainability is, as you see here, sustainable fishing practices support natural ecosystems and don't harm the environment. So this can be in a natural situation where fish are wild and line caught, or it can also be in a farmed situation. Some fish are farmed, so they're in special aqua farms and pens, and they're fed and raised, and that's not necessarily a bad thing. It just depends on how it's done and what the impact it has on the environment. So if you are interested in knowing more about the sustainable fish, which fish are better to buy for the environment, I'm going to invite you to go to this website. It's run by the Monterey Bay Aquarium. It's called their Seafood Watch program. And they have listings. You can look up type of fish that you like to eat. And it's a sort of a stoplight system, so it's red light, yellow light, and green light. And green light choices are best choices. They don't harm the environment. They're caught or raised well and responsibly. Good alternatives are okay, but you want to watch out, and we'll have more information on that. And then avoid. So those are the ones that are raised or caught in such a way that it's damaging to the environment. And this final slide is from the Monterey Bay Aquarium itself. This is their definitions of best choices, good alternatives, and things to avoid. So again, take a look at it on the internet, and I believe that there are some stores that use these criteria. I know Whole Foods has some sort of a criteria for sustainability, though I'm not sure if they're actually using the Monterey Bay Aquarium, but they have their own criteria for sustainability.